Hello, I am here to talk to you about something called systems. Okay, so what are systems? Systems are when you have more than one equation and you want to know what the solution of those two equations are. And we are going to use linear equations. So our linear equations, if you graph them, there are some different things that might happen. So most students' favorite way to solve systems is by graphing them on a grid. So look at these two lines. So let's say you graphed two lines and you found that they have an intersection. Well, lines can cross at one spot. That would mean one solution. So anytime you see two lines that are intersecting, if they say, what's that solution? You got to go find that ordered pair. What if you graphed, though, something that did this? They never crossed. They were parallel. Remember the word parallel? Parallel means that they will never intersect. To be parallel, the two lines have to have the same slope. So it looks like if I were to count up and over, up and over, up and over, up one, right one, up one, right one, up one, right one. This has a slope of 1. Same thing here. If I count and go up one, right one, up one, it keeps on doing the same thing. It also has a slope of 1. So when two lines have the same slope, they cannot intersect. That means there is no solution. Now, one other thing that could happen is you may not even realize it, but you actually have the same two equations. And when you graph one and then graph the other, it lands right on top of the first one. So every single point along here is the same as every single point underneath there, which means you have infinitely many solutions. So when your two equations are the same, this is what happens. Now, let's look at some certain special situations here. So if I were given 6x equals 9 minus 3y and 2x plus y equals 3, I've got two equations and I want to graph them. First of all, it's really hard to graph something if it's not in slope-intercept form. It would be nice if it was in y equals mx plus b. Well, sometimes that's not always easy to put it into that format. Now this one is. I can simply take that 2x and move it over there in front of the 3. So that would be y equals, remember when it moves, when it's changing sides, it is going to change to the opposite sign. Because if I wanted to take it off of this side, I would subtract it. What you do to one side, you go do to the other. So you would have to subtract it from this side as well. And remember I said I like to put that in front of the other number. So I would have a negative 2x plus 3. All right, so that one's not so bad. I can go graph it. Remember you want to plot your y-intercept. So plot the 3, and then your slope is negative 2 over 1. Notice how it's negative. That means I need to go down 2, right 1. Down 2, right 1. All right, I'm going to grab this line. It looks like it might go right through it for me. Perfect. So now I want to graph this one. It is, I can do it. I can move that 9 over there and then divide by negative 3. But I thought I would show you another way to graph. Let's use something called intercepts. So this is nice when I'm not so great at solving for y. So I'm going to put a 0 in for the x, find y, and then the next time I'm going to put a 0 in for the y and find x. So if I put a 0 here, 6 times 0 is 0. So that whole thing is a 0 now. So 0 equals 9 minus 3y is my equation. Okay, well now all I have to do is move the 9 to the other side. When it moves to the other side, it becomes a negative 9. So negative 9 equals, let me change colors here. negative 9 equals negative 3y. All right, divide by negative 3. Negative 9 divided by negative 3 is a positive 3. Okay? So I'm done with that one. I replaced the x with 0. It wiped that out. I moved 9 to the other side. It became negative 9, and then I divided it by the negative 3. Now let's plug in a 0 in place of the y. So 3 times 0 is 0. So this is all gone, and I just have a 6x equals 9. Well, I got to divide that by 6. So I get an x equals 9/6, which is 3/2. That reduces to 3/2. That's the same thing as 1.5. So 1.5. So if I go over 1.50, let me color coordinate this. I'm going to plot that point in pink. I'm going to plot this point in this green. Interesting. Look, it landed right on top of that line. That means my new line is going to do the same thing. So guess what? How many solutions are there? Infinitely many. So many I cannot even count. It has infinite solutions. Because these two equations apparently are the same because one line ended up lying right on top of the other. All right, let's try this again. So this time my two equations are this one and this one. All right, I am going to graph this one in red. So I've got a 4, go up 4, do my slope of 9/4. Now I want to show you something. If you try to go up 9, you go off the graph. This is normally up and right. But if you go up and right and it's not going to fit for you, you have to do completely the opposite. Down 1, 2, 3, 4, 5, 6, 7, 8, 9, and left 4. 1, 2, 3, 4. Okay, let me count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4. I had to go down and left because I needed to do complete opposite because that was going to go off the graph. So here's my line that's going to cross through those 2 points. Let me turn that line red. Good. So I'm going to erase this stuff. Let's go plot this one in blue. We always do our y-intercept first. This time it's a negative, so that is down. If my denominator is positive, that's right. So let's see if it will fit. So from the 8, so from here, I got to go down 4. 1, 2, 3, 4, and then right 3. 1, 2, 3. So I'm going to go plot a line through that, those 2 spots. I'm going to color that blue. So look, my intersection is right in there. It's in no man's land. I cannot name that ordered pair and feel perfectly confident. It looks like it's about 1.26½, but I don't know for sure. But I do know it has one solution. So sometimes graphing it will not get me the exact spot. I mean, I can see that there is an exact spot there, but I don't know without estimating what the spot is. Last problem. So this one's actually going to have no solution, and I can tell real quick that it is because, first of all, when I put this one into slope-intercept form, when I move this over to the other side, it's going to be a y equals, that's going to become negative 3x plus 3. And look at this. This is already almost in y equals. It says y equals negative 3x. I just need to move my 2 to the other side and make it a minus 2. So I'll cross it off and put it over there. Look, my slopes are both negative 3. Now this one's negative 3x plus 3, and this is negative 3x minus 2. So I know this one's going to go through the 3, positive 3. Now let's see if this is already 1, 2, 3, right 1. Yes, it is. And this one's going to go through negative 2, 1, 2, 3, right 1. So this has no solution because when I graphed them, my slopes were the same. If you have the same slope, your lines will be parallel and it will be no solutions.